Which one? Which one?
2.24.
Okay, is there anyone before 2.24? Before, in other words, 2.21 you good with? 2.2.2, 2.2.
Let's do 2. Oh wait, let's do. What's 2.22? Oh, you
2.1.
that one.
That one, the one that we were with the trade.
Yeah, that one's the one with the sign.
Wait, get 2.2-3?
Yeah,
Or
2-3 is the one with the exponential.
All right, yeah, all right, well, exponential or
Yeah.
sine? Because,
The sign,
That
the
one's
cosine is
the one
2.
I get 2.4.
all right, like, give me the problem exactly.
For 2.3,
Yes.
let's see, fx of the x equals a parentheses 1 minus exponential negative parentheses x minus 1 close parentheses close parentheses.
U of x minus 1?
Yeah, and then, or, hold on.
There is no.
Yeah, there's no ux minus 1. You can get rid of it.
Well, it's gotta be valid only for x greater than 1, right?
It's 1 to infinity.
Yeah, that means it's greater than or equal to 1. In other words, what I'm trying to show you is this. Here's x equals 1, if this is x.
Okay.
The only time this is valid is up in this area. And if you look at this, at x equals 1, this is e to the 0, which is 1. 1 minus 1 is 0. Follow me? So it's 0. So it starts here, and then what's going to happen, it's asymptotically going to go up and up and up and hit 1 as x goes to infinity. That's the idea. Can you follow me? That's the reason I put u of x minus 1, because that way you'll know there's no values for x less than 0. Everybody follow me on this, guys? You have a question still or not?
That makes sense.
That's the only thing he's saying. For x less than 1, it's 0. Now, what is this density function, or I should say distribution function? Well, technically, f of x is the integral, right? Technically from minus infinity, but it doesn't matter because it doesn't exist until you hit 1. From 1 to x of that entire thing. And sorry, the density function of that entire thing, dx. So if we had the probability density function, we could say we could get f of x. Capital F of x is the distribution. It's the integral of the probability density function. Does everybody understand the concept? Are you clear about this?
Okay.
So these have to go to 1 when you reach the end of the upper limit. If they don't, you do not have a legitimate function, right? So as this goes to infinity, this is you can do it 5 different ways. If you take a look at this, we know in the limit, as x goes to infinity, that's the upper limit of f of x going to infinity. It has to go to 1, right?
Yeah.
Can you see it back there okay? All right, you with me on this one? I gotta make sure everybody's. All right, well, if you look at this, what's the value of this exponential at infinity?
0.
It becomes 0. E to the minus infinity minus 1 is infinity. E to the minus infinity is 0. So it's 1, right? And it's times a. So that means if this has to go to 1, a is 1. That's it. There's nothing more about that that becomes in any way confusing. Correct?
Yeah.
What's the next part?
See,
F x of 2.
yeah.
Pardon me?
F sub x of 2.
Capital F, the distribution function. Well, you just plug in 2 for that. What do you get? F x of x equal 2. Now that is not 0 because this is a distribution function implying the integration of f of x from where it began, technically minus infinity, but in this case 1 to 2, right? And what's this going to be? Well, if that's 1, it's going to be 1 minus exp. If that's 2, 2 minus 1 is 1, e to the minus 1. And what is that?
0.632.
Pardon me?
0.632.
Is that the right answer?
Yes.
Okay, this shouldn't be a hard one.
Makes sense.
What's the next part?
Was the probability that the random variable lies in the interval 2 to infinity?
All right, so you guys tell me this. Now, think about this. This is the integration of f of x, right? So we want the interval from 2 to infinity. We want to know the probability it's between that. What would it be natural? Think about it. What's the probability it's between 1 and infinity? Tell me that. 1. What's the probability it's between 2 and infinity? 1 minus the probability it's between 1 and 2. Does that make sense to everybody? You good with that?
Yeah.
All right, let's see what it is. So that means the probability that x is greater than 1, less than 2. Oh, I'm sorry, from 2 to infinity, right?
Okay.
I'm sorry. So the probability that x is greater than 2, less than infinity, is equal to 1 minus f of x of 2. You're going to have to help me with that. It's 0.3 something, I think.
68.
Pardon me?
0.368.
All right, so it's 0.368. And that's just simply taking the prior value and subtracting the prior value from 1. Is that the right answer? What's the next part?
Was the probability that the random variable lies in the interval 1 to 3?
How do we get that? All right, think about it. Remember the definition of this thing right here. It's the density function, right? From 1 to 3, right? Wouldn't it be 1 minus the probability it's between 3 and infinity? I mean, how did you guys want to do this? I want to do one thing in this one, just because here's where I see confusion all the time. At least I suspect there might be confusion. What I want to do is get the probability density function for this. All right? Because if I got the probability density function, I want to know the probabilities between any two values. I simply integrate that between the values. Do you agree with me? Yeah.
So if we're given the probability distribution function,
We don't
why
have.
would we not just do
We could.
f of x 3 minus f of x 1?
All right.
Why would we
So.
not do that?
No, we can. The only reason I was doing that, I wanted to just show, I wanted to somehow work in getting the
Okay.
probability density.
Okay.
What he's really saying, since this technically means the probability of something between is less than or equal to this value x. That's what this is. So if we wanted it between 2 and 1, or what was it, 2 and 3?
1 and
1 and 3.
1 and 3. So the probability of it being less than 1 is 0. Do you agree with that?
Yeah.
So the probability of being less than 3 would be fx of 3, right? So it would be just fx of 3. Do you agree with me? I mean, that's the rationale. But I want to do the density function just because you're going to be doing this all the time. You have to be able to work with probability density. What is the probability density function? It would be the derivative of this. This is real important. So I know the probability density function of x is going to be equal to the derivative of f of x with respect to x. I'll make a caveat that this is only going to be good for x greater than or equal to 1. Below that, we could put a u of x function, u of x minus 1, to get rid of the possibility of it having values less than that. Does everybody follow me on this? So do the derivative and tell me what you get. A is out in front, right? What's the derivative of 1 with respect to x? 0. So it's going to be the derivative of this, right? Now, you can do this a couple different ways. People oftentimes get themselves confused there. I can write this as e to the minus, or to the plus 1 times e to the minus x. Do you agree with that? I mean, you don't have to do it that way. Do you agree? Then you can take a derivative of that. You can see it's just what? Minus
1.
It's going to be minus e to the 1, e to the minus x, right? Do you all follow me? And then you got another minus sign, so that goes away. At the end of the day, what happens? You get e to the 1 times e to the minus x, right? And that's just e to the x, e to the 1 minus, or x minus 1. Follow me, class? So this would be simply exp to the, and this would be parentheses 1 minus x the way he's doing it, right? And we can get rid of this and just put u of x minus 1 to make it only valid for, or only non-zero for, sorry, have no values less than x equals 1. That would be the density function. Does everybody agree with that? Now, anytime you want values, the probability of some, first, does everybody understand what I did and why I did it? I don't mean to go too quick. With me on this one? Now, if we have that, if we wanted the value, and this is the one thing, I want the value between any two values. Now, I can do the distribution function, but I just want to make sure it's crystal clear. If I want the probability that x is greater than some a less than b, that's simply the integral from a to b of the density function of f of x dx between those 2 points. And it doesn't matter what f of x is as long as it's a legitimate probability density function. Does everybody agree with that? Now, one other thing in the book, or in the notes and stuff that he talks about is you can't get any information about the mean, average value, mean squared value, standard deviation, or anything of that interest from this distribution function. You need the density function. That's the reason I'm harping on it a little more than usual.
So you get more information by going distribution to density.
If you have density, you can get everything else. If I give you this, and I ask you for the average value, you can't. You need the density function. Let me just continue on with this. So this function right here, the density function itself, since a is 1, it's just what? E to the minus, and it's quantity 1 minus x, right? U of x, that would be a legitimate density function for, because a is 1. Do you agree with that? Now, I want to just continue it. This will take me to where I want to go today. A couple of things. So if I wanted to find the average value of x, how would you do it? I'm going to do it right here. We don't have to go through the math completely on this, but you'll see it becomes very obvious. So what is the expected value of x? Well, that is x bar, right? The average value. Now, I'm doing it just for this problem. I think this occurs later in problems 3-4.
Yeah.
Huh?
3.3 to 3.2 to 3.4.
All right, you're going to see all these kind of questions come up, but it's natural to do it right now. Okay, so for this, what do you get? Well, I take the density function that I have there, and I'm going to do it this way. I'm going to say, see how this can be rendered as, it's x minus 1, pardon me, x minus, or 1 minus x. No, x minus 1, sorry. You know what I did? I had this backwards. It should have been like that. Now, if you have this here, then this can be rendered as e to the 1 times e to the minus x times u of x minus 1. The only thing I'm doing is breaking e to the 1 out. It's a simple constant. You agree with that? All right, now back to this expected value. Here, I've got to integrate, and I'll write down the formula. X times f of x dx, and I have to go over the entire range from 1 to infinity. So here I get my average value as the integral from 1 to infinity of x. And now I put in that, see, it's just going to be e to the 1, e to the minus x. I'm going to take e to the 1 outside. And that means it's x times e to the minus x dx. What kind of integration is that? Anyway, do you see it?
Parts.
Integration by parts, right? Do you remember doing those things? All right, now I'm going to say this. I think a lot of calculators can do this symbolically. Am I right? Or not?
Yeah.
You're right.
Can the Inspire? Is that?
Yeah, okay.
Yeah.
This is fine.
Pardon?
This is HP.
That's an HP?
Yeah.
It probably can too, but I don't know how to do it on it.
Thanks, Mark.
You got Inspire? What do you guys have? What do you have?
Inspire. But it can do it.
They can do it.
All right, I would do it with limits, actual limits. You don't have to put infinity unless you have the ability to. Like sometimes they have INFTY or something like that. You can just make it a large number. This is a numerical value. I mean, it's going to have a value, but if you wanted to do integration by parts, how do you do it? Well, you get me that. Remember this? Derivative of uv is u dv plus v du. I do it that way. You can do it any which way, right? So if we look at this, for this, we can let x be u if you want. Doesn't matter. So we can say u is equal to x, du is equal to dx. And then we can say dv, right, is equal to e to the minus x dx. Do you all remember doing these things? You all remember? I mean, I never liked these things, because especially when they get long, we have to do this 3 times. All right, so if we have that, that means v is what? Well, you have to integrate that, right? And what do you get? You get minus e to the minus x, correct? You with me on this? And it gets rid of that. So now if you say, so if I want the integral of x e to the minus x dx, I'm going to say that is a u dv, so it's right here, so it means it's equal to the integral of d of uv, or d of ux times v, which is going to be a minus e to the minus x. And I better put the minus sign up. So it's minus d of x e to the minus x. And then it's going to be that minus the integral of v du, and v is equal to, I got a minus here, so it's minus the minus e to the x makes it plus e to the minus x, and then du, which is going to be dx. Now, I didn't put the limits on for a reason. I'm sorry. I don't mean to be running through this too fast, but you all understand the concept? I always start here, because this is something everybody understands. And from here, now you can set the limits. This goes from 1 to infinity, right? This goes from 1 to infinity. And this goes from 1 to infinity as well. The Greek class. And I'm not putting the, I didn't put the e to the minus, did I erase? I guess I did erase that. This one, when you break it out, it's going to have e to the 1 in front of all what I'm going to get. Do you follow me? So what does this become? We want this value. This becomes, well, the integral of a differential here becomes the differential. So I have to evaluate this at infinity. Well, e to the minus infinity goes to 0 faster than x goes to, e to the minus x goes to 0 faster than x goes to infinity. So that's 0, so it's that minus a minus, so it's going to be 1 e to the minus 1 here for that one. You all agree with that? He's going to tell me if I'm right. And then what's the next part? Plus, the integral of e to the minus x dx is minus e to the minus x, right? When you evaluate it from 1 to infinity, it's going to be what?
0.
No. No. This becomes what? E to the minus x with a minus sign from 1 to infinity. You can switch these limits, make that plus, put this as infinity, make this 1. It's e to the minus 1, isn't it? You all follow me? So that's going to be plus, so I've got 1, and then e to the minus 1 here. I've got that twice. And that would be the value of, unfortunately, I erased it. When I look at the second moment here, this actually becomes the integral, and I put e to the 1 out in front of 1 to infinity here. And then I have x e to the minus x dx. That's what I wanted. Now I have this value, x e to the minus x, but it's times e to the 1. Just watch this. So here I have e to the 1. Now what is this? Just 2 times e to the minus 1, right? So what's the value of 2? Did you get that? You all with me? That's integration by parts. A lot of you, if you have calculators and I give you a problem where you need to use integration by parts and you want to use your calculator, just say, I use my calculator, this is my result. But make sure you do it right.
Wait, so the Inspires are able to do it with Infinity?
Yeah, there.
Does it have an
Is
INFTY?
it titanium?
Or you can get the
Is that what it says? Listen, do you have one? What do you have?
I just got a TA equal plus.
I don't think that does symbolic.
No, I don't think so either.
But you know, the thing
It does
is,
intervals, yeah, but
if
it's
you
not-
have an
it has to
actual,
be finite.
but that, just put in, instead of putting infinity, put 1,000.
Oh, true. And then it'll be like 1.99, whatever.
Ah, come on, it's too.
Well, yeah, I know, but I'm saying.
Yeah. All right, do y'all follow me on that one? I wanted to make sure I'm clear. How would you get, no, if you want to do it, we will. But how would you get the second, or how would you get the mean squared value?
X squared.
All right, I'm gonna go back to here, but I want to mention, this is a great problem. It's an example of how you have to work this out. Remember, suppose you're given a density function, and out of that, now I ask for the mean value, the mean squared value, and the standard deviation, which is a legitimate thing to ask, right? Okay, so if I wanted mean squared value, it would be this, right? The expected value of x squared, correct, class? Take a moment, make sure you see this. By the way, I brought coffee down, so. And I also took something that hopefully will prevent any kind of problem with mold or whatever this is down. Nobody else has this problem, so no? Maybe it is lack of coffee. All right, so back to this thing. I now need to do this, right? So mathematically, how many of your calculators, I bet your yours can do this.
Yeah.
If I do that, what do I get? I get the integral from 1 to infinity of, now it's x squared, and then it's times e to the 1, which I can take out in front, times e to the minus x, right? And it's dx, isn't that right? A is 1, correct, class? Now, that one is kind of interesting.
Let's do it twice.
Well, you could do it that way. I was thinking there might be a trick right here. Hold on. Yeah, I think you are going to have to do it twice. I don't want to do it twice. Can your calculator do that one?
So
Yeah.
5.
Would you?
5.
5?
Yeah.
I bet you it's a quick way to do this. I'm just trying to think. No, well, I already erased the result. If I had a result of x e to the minus x dx, if I left that up there, integrate from 1 to infinity, then we could use that part and just say x squared e to the minus x and do the u to u again. So it's 5?
Yes.
Okay, now, last thing, I want to see how many people just kind of remember this. Do you remember now the expected value of x minus the mean value squared? The symbol for that is the variance, right? Right? And the variance, do you remember me doing this? If you multiply these things out, these are linear operators, so if you go ahead and you square this, you get what? You get the expected value of, one last time, x squared, right? Minus 2 times x bar. X bar is a single value. And then it's going to be what? Plus x bar squared. I'm just showing you when you square that thing, right? I know I didn't give you specific, I didn't say I was going to quiz you on this, but please be attentive here. This is important. All right, now, this is a linear operation, so now I can go ahead and say this is the expected value of x squared, which I have. Now it's minus 2. Well, x bar is a constant, right? And the expected value of x is x bar, right? So I can just say it's really going to be x bar squared. That's my point on that one. Do you agree with that? Finally, the last part is just a constant. So it's minus x bar squared. I said this last time. This is the value, that's the mean squared value that we have there is 5, right? 5 minus, and you can see, wait a second, that should be plus. So now you can see that I have 2x bar squared plus x bar squared, or it's just minus x bar squared. Do you agree with that? Maybe I should put this down. So this is really expected value, or really, call it this, x squared bar, it's mean squared value, minus x bar squared. So it's 5 minus, and it's 2 squared, which is 1. So that would be the variance. What's the standard deviation? That's variance. Standard deviation is sigma, right? If the variance is 1, what's the standard deviation?
1.
1 as well, right? So I'm use that problem to really kind of showcase some of the other things that you're going to need to understand. But it's a good problem because you're going to be asked that question later. We're right on it. What's the next problem?
The 2.24.
Oh, so it's the cosine thing. You have to change to a sine.
Yes,
But follow me on this one. I think the solution's up there, right?
it is.
I'm going to put up all the solutions to these. To the chapter 2 and 3 and 4 in this book, Cooper and Miller. Now, is it supposed to rain today or tomorrow? Or tomorrow?
Yeah.
Nothing today? What time tomorrow, do you know? It's a selfish reason I'm asking. I'm not just trying to break it from the knot. I want to go fishing.
So the around noon.
Boom.
Best time to fish is
Different
before it
weather
rains.
app. No, go ahead. 2.2-4.
Yes.
All right, so give me a heads up. I think I remember this. Go ahead.
So when f of x is equals 0 at the boundaries of, this is big F,
Oh.
distribution function f.
All right, hold on. This is kind of a cool problem, though, as I recall. All right, so capital F,
Capital F,
Fx, x, right?
yes, equals 0 between negative infinity and negative 2.
Up to 2? What, we're going to put a u of x minus 2. Just, what's next?
Then the probability distribution function is a equals,
A?
a times 1 plus sine b of x. B times
All
x.
right, that's right. It won't work with a cosine. Sine b of x.
Yes.
And this is going to be times u of x minus 2. So I put it that way. It's the same thing as it's 0 for x less than 0. Everybody knows what a u function is, a step function. Whenever the argument is negative, it is 0. So if x is 1, 1 minus 2 is negative 1, it's 0. So that's the distribution function. And it asks for, and this is valid up to what point?
Negative 2 and positive 2.
Okay. So actually, maybe I can do that. This is good for x greater than or equal to minus 2 less than or equal to 2. And it's 0, or I'm sorry, it's 1 for x greater than 2, right?
Yes.
Okay. In other words, if you were to graph that, at minus 2, and it is minus 2, right? All right, that's where this thing starts, and it goes up like a sine. So basically a sine function, you know what it looks like, and it's doing this. It has to go, it's an odd function, so it's going to go, sorry. Basically in here it has to be 1. At x equals 2, it has to be 1, and at x equals minus 2, it has to be 0. Does that make sense to everybody? Because the distribution function right there, f of x is equal to the integral, and I'll start at minus 2 to x of f of x dx. And this is good for x greater than or equal to minus 2, less than or equal to 2. So try to give you at least a mental picture. It's going to asymptotically approach 1. And this is f of x. Getting back to this one. So think about this. You're going to have at least 2 conditions because we have 2 unknowns there. Do you agree with that, class? So if we have two unknowns, we know f of x, and I think he does it this way. X goes to, in this case, 2 has to be 1. Do you agree with that? So that means I have a, and this is going to be 1 plus the sine of b times, or 2b. That's one condition. We also know f of x as x goes to minus 2 is 0, correct? These are the, you have the solutions, right, available to you for this? I think he does it this way. So that means what? That's a, and it's 1 plus the sine of minus 2b, right? You agree with that? Now, what's the thing about a sine function that you have to be aware of, and cosines, you have to be aware of these traits. Sine is an odd function, so if you were to plot sine of x versus x, on the upper half it does this, and the lower half it does this. If this is minus pi and this is plus pi, you can see that's the way it goes, right? Now, the thing about this is it's an odd function, so the sine of minus x is actually minus the sine of x because it is odd. Does everybody understand when I say odd or even function? And the way they used to explain it is an odd function is something, if you take it, fold it twice, fold it this way and then this way, if you had paper, that's an odd function. If you only have to fold it once and it overlaps, it's an even. So cosine is an even function. All right, based on that, what can you do?
Take the negative out.
Well, exactly. Now you can do this, these guys. You can do this, right? And now what can you do? Can't you just add them up? Add this two, what do you get? 1 equals 2a, right? A plus a is 2a. A sine 2b minus a sine 2b is 0, so it's just 2a. Do you agree with that? That means a is equal to 1/2. All right, how do I get b?
Plug in
Where? You're right.
into 1.
Well, what can you do? If you're here, right, you know that's 0. All right. What does that imply? It implies this has to be 1, right? So what argument of sine of something, or what makes sine of theta equal to 1? Pi over 2, right? 90 degrees. Do you agree with that, everyone? I want to make sure. Do you follow me on that? So if it's 90 degrees or pi over 2, you can say that this tells me that pi over 2 is equal to 2b, or b is equal to pi over 4. Do you agree with that? But do you understand the reasoning or not? Do you follow me?
Explain it one more time.
Sure. If the thing I'm doing here is I'm using these two conditions to evaluate both A and B. To evaluate A, I just add them together, and I can see I'm going to have 1 on this column, and I'm going to have 2A on this column. Now, if I take a look at the second part, right, I can go down here just with me. I know that this is 0, right? I know A is equal to 1/2, right? Where are we at? Right? All right, we can multiply both sides by 2, get rid of that. Now, I know the only way this is going to be 0 is if the sine to 2b is equal to 1. So when I say sine of 2b equal 1, now I think about what does a sine function look like? Over here, you got it, right? Where is it equal to 1 over the initial period? Right? That's 1 at pi over 2 radians, correct? And that's how I determine that. But really, this isn't meant to be tricky. So I take that argument 2b and I set it equal to pi over 2, and therefore b is pi over 2. That's all. And if it's not obvious, just think about it. It'll come to you. This is not obvious. What's the next, by the way, does he ask us for something else from this problem? What else?
Find the probability that x is greater than 1.
All right. Now, I want you to think about this for a second. Before we just mess around. X is greater than 1?
Yeah.
And we have f of x, right? Okay, let me ask you. You think about it just for a second. Did I put my integral? Yeah. F of x is really the integral of density function from the lower limit is -2 where it becomes non-zero to x as long as x doesn't exceed 2, right? So if I wanted the probability it was between -2 and 2, it's got to be 1, right? If I wanted the probability between it's between -2 and 1, right? I can say -2 to 1. Well, that's really just capital F of x of 1, isn't it? Take a moment. With me? Does everybody follow me on that? So if I have f of x of 1, I know the probability it's less than 1, or it's between -2 and 1. If I wanted to know the probability it's between 1 and 2, it's 1 minus that, because 2 is the upper limit. Do you agree with that? So I can say the probability that x is greater than 1, less than 2. 2 is the upper limit. It has to be between -2. So I can just say this is going to be 1 minus capital F of x equal 1. You're going to have to help me with this. So what is that? 1, that's going to be minus, a is equal to 1/2, isn't it, class?
Yes.
So it's 1/2, and then it's going to be 1 plus the sine of pi over 4, and this is going to be times 1 sine of pi over 4. Let's see if this answers right. I think I did this one. So it's going to be 1 minus 1/2, and then it's going to be minus 1/2, and the sine of pi over 4 is 1 over square root of 2. And so that's 1/2, so it's 1/2, you can take that out in front. It's 1 minus 1 over the square root of 2. Can you tell me if that's the right answer? What is it? What's the right, what's the value? I want to put it up there just for completeness.
0.146.
Is that correct, Les? Is there another part to this one?
Find the probability that x is negative.
I think this one we can talk our way through. Well, what could you do? The probability it's negative is it's less than or equal to 0, right? So that's f of 0, f of x, where x is 0, correct, class? What is it? Well, the sine of 0 here is 0, right? So it'd be exactly 1/2 if you just look. Do you agree with that? What else?
Let's see.
That's it.
I mean, that's it for 2.4.
I got one for you. I got 2. For you, Nick. I think you know what I'm talking about. First, since you're given a distribution function, which is odd, usually you're given a density function. I mean, statistically speaking, that's usually what you have. But based on this thing, now here's a few follow-up questions. First question is, what is the probability density function? And you can put the range, just specify it's x greater than -2, less than 2, and you can do that. So what is that going to be, class? Say again? How do you get it always? You do
Take
what?
the derivative.
Derivative of the distribution with respect to the value x in this case, because it's a function of x. What's it going to be by looking? Well, the derivative of the first part is 0. A times sine x, sine of pi over 4x. Well, the a is equal to 1/2. Do you agree with that? Now, I got sine of pi over 4x. I need a derivative with respect to x. What is derivative of sine?
Cosine negative.
And it's cosine, right? But the pi over 4 comes out in front. Do you agree with this? So now I get 1/2 times pi over 4, and now it becomes cosine of pi over 4x. And this is valid between, it's 0 otherwise. So it would be pi over 8 cosine of pi over 4x. Do you agree with that? Let me just write this down. So I have pi over 4 cosine of pi over 4x. I don't know if they asked for this, but they should. I think they might. That's the reason I'm doing this. Okay, I got the density function. Now,
Shouldn't that be 8 in the bottom?
oh, you're right. Thank you. I make mistakes. Sorry. All right, now, if I have that and I wanted the average value, do you guys know, and just I'm not talking, you know, right?
Yeah, just
Well, let's write it down. The expected value is what we're asking for, right? And that's symbol is x bar. And mathematically, it's what? It's the integral over the entire range. For, in our case, it's minus 2 to 2 of what? X, correct? Times what?
Pi over 8.
The density function, right? So I'll put it in. Pi, you're going to see something, over 8 cosine pi over 4x dx. Do you agree with that? Now, I have a question for you. I'm going to show you something. I think this is a nice trick. Just take a look at this for a second. Do you see that the cosine of pi x is an even function? If you integrate an even function from over the same, from minus a to plus a, you get twice the integral from a to the upper limit of 2. You all agree with that? Of just cosine. X is an odd function. Do you agree with that? Odd times even is odd. This is an odd function. The entire thing is an odd function. If you integrate an odd function from minus a to plus a, regardless of what a is, it's 0. Just integrate x dx from minus 2 to plus 2. What do you get? 0. The area, the negative area is the same as the positive area, in other words. So this is 0. This is a nice one. Really great one because it's simple to do. I didn't have to do integration by parts. All right? Stay with me on this one. So, what is going to be the mean squared value, mathematically, up here? Why don't you tell me?
just x squared.
Well, an integral from minus 2, you're right, to 2 of, and now it's x squared times that cosine, correct, right? And pi over 8, that's just a constant times cosine of pi over 4x, right? dx. Now, this one's different. X squared is an even function. Even times even is even, right? Just take a moment. Please make sure you see this. I'm trying to show you some tricks that will make life a little easier. So, because they're both even, what I do, I can go ahead and get rid of this lower limit and start it at 0 and put 2 here. Are you with me? Now, at this point, the way you do that integration, you can take the pi over 8 out in front, you get really pi over 4. Right? I have x squared cosine of pi over 4x dx. Have you had common here or not? Okay, pretend Retugnate will make you do a lot of trig identity and trig tricks with integrations. I don't know if this one occurs much in common or not. But if you look at that, there's probably 2 or 3 ways to do this. One way is this cosine here can be expanded in terms of 2 exponentials. It can be e to the plus j of the argument pi over 4x plus e to the minus j pi over 4x divided by 2. That's one way. Do you all remember this? This is Euler's identity. Then you would have the form of x squared e to the x if you wanted to do integration by parts on this. That's one way. I mean, obviously, that kind of an integral takes a little more thinking, right? I don't think there's a quick fix to that one. But that's how you would do it. I mean, that's how I would do it, probably. And there may be a trick right off the bat. If you x squared cosine ax dx, there may, I don't remember the actual expansion of that, but I'm sure there is a trick.
Yeah, I remember on Cal 2 there was a trick for doing by parts, but like when you have like a x squared or whatever,
Well, I
where you
mean,
could like go down the line.
Yeah, you can use tabular integration for 0 and then multiply across.
I can't even remember.
do you remember how to do it?
Yeah.
What would you? No, I mean, you don't have to show me.
So it'd be like x squared, and then you would take the derivative of that x squared term, and then you would do the integral of the cosine term. Because the cosine term or the natural
You're
log
right.
term is going to oscillate, then it doesn't go to 0, but the derivative term, x squared term, goes to 0, and then you multiply positive, multiply negative, multiply positive.
And we'd have to spend a little too much time on it. But I'm going to tell you that's the way I would do that. Other questions? I know I've got about 20 minutes. Other questions? Don't ask. Nothing. All right. So here's. I'm going to just mention one thing and you get your quiz. Okay. I'm going to do the conditional. I'm going to do probability. If you have like hopefully at least this is enough to get you going with moments and stuff like this. But I want to just mention this next part, and I'm not even gonna. I could do a problem, but I'm going to just talk about this. And it's in the PowerPoints. I'll tell you what pages to read, and then please do these for Monday. I'm going to put up because this stuff. Here's where it starts getting hairy, in my opinion, for this level. So, if I have a probability density function, say f of x, and it's simple, say e to the minus x times u of x here, something real simple. So this is it's a density function, right? And if you integrate that, you get minus e to the minus x. And if you look at this, the u of x limits it from 1 to infinity as possible values. It will have a value of 1 for the integral, the area under that curve, right? Now I give you a function, and I'm going to say y is equal to 3x plus 2. With me? And I have f of x, and what they're asking for is what is f of y of y. They want the density function as a function of y. You with me? Now this is in the notes, but this is a very reasonable thing to ask now that we started with probability density functions. The way you do that is start over here with, well, what is f of x of x? Well, it's equal to what? E to the minus x integrated from 0 to x, I technically should prime this, but I'm not, of dx. That would be the density function, capital F of x, right? Now, if I look at this, if I have y minus 2 here, and if I divide it by 3, now I get x. This is actually a random variable, but I'm sorry, I'm not distinguishing it right now. I'm just getting to the point. You with me, class? All right, now I can say my f, I can call it f of x of y, which is really going to be like f of y, would be the integral from 0 to where x is, which is y minus 2 over 3, of this, which is e to the minus x dx. Can you all follow me on this? The only thing I've done there is replaced x with its value in y. So now I have a density function theoretically here, right? I mean, a distribution function. Does this make sense? Make sure you keep me straight. If I'm not being clear, I want to hear from you. So if I have this, and I wanted the density function, probably I have to take a derivative with respect to y. Here's where you got to just understand there's a law. So when I want f of y over here, now I'm going to say f of y would be equal to the derivative with respect to y of that density function, but I just made one up. So it goes from 0 to the upper limit, which is y minus 2 over 3 of e to the minus x dx. Do you remember this? There's a thing called Leibowitz's rule on this one. All right, so the way this goes, when you're dealing derivatives, you're looking at the upper limit. And the way way this works is this f of, and it's in Tom Benny's notes, f of y is going to be this functional form evaluated at this upper limit. So it's going to be exp to the minus quantity y minus 2 over 3. But then you have to take a derivative of this upper limit right here with respect to y. This is in the notes. Do you remember seeing this, anybody? Or not?
No, but this is in the homework. There are 2 questions like this.
So you take a derivative of this with respect to y. What do you get? 1/3. You all see that? And that is the density function. But the way you start these, and I got to tell you, these things can be tricky. Now the lower limit here is not a functional form of y. If it was, we'd have to take a derivative here. We take the upper thing that I just did. In other words, take e to the minus this value times the derivative of this value. But there would be minus e to the lower limit, whatever that is, times the derivative of a y function there. Now, that's if you have something where an x squared or something, but I'll talk about that later. Can everybody follow me on that? Now, if you look in your book, he has problems. I gave you, look at the note set. That's mine. If you look at that note set in there, he has questions related to this exact problem. And in the slides, if you look at Denny's slides, they're fantastic. He does exactly, he really did a good job of that. I used to have a kid in class, he'd text me instead of just raising his hand. Drove me nuts. Dang. I have a question. Hey there, dude. Pop. Some people are very shy, especially in big classes. my parliamentarian, my Senate chair, he would text me instead of, he's right there, just tell me what you're thinking. So if you look on 2-3.3, you can see that exact thing, but this is an x squared one, so you have to take the lower and upper limit. Then I'm talking about that. But look at 2-3.4. If you take a look at that, same exact form. You all with me, class? We'll talk more about that on Monday, and we'll ask you to do these problems. Now it's about time for the quiz. So can I separate you all by use the desk? I'll tell you what, can you guys like hop behind those two, or and then you guys can no matter what, I'm not going to get my way. Not gonna